be made harder and were able to drill holes in harder metal stock. By the early 1900s, drilling machines were being used to build sewing machines, bicycles, and watches. Drills that could cut 30 or more holes at a time were used to machine engine blocks.
Hole making happens to be the most common metalworking operation in industry. We make a lot of holes. Drilling machines come in all kinds of sizes because we make small holes, we make very large holes. Hole making is just so common that it's essential to manufacturing in almost every industry. I think some of the most impressive drilling machines today are those designed for high-speed hole making. Typically, these drill at speeds that you can hardly see the hole making process. It's so fast. Certain workpieces require hundreds, even thousands of holes. So the faster those holes can be made, the more efficient the drilling machine has to be.
The advances of the 1800s that led to better drills also led to a new type of machine tool, the grinding machine. As early as the 1500s, Leonardo da Vinci was drawing sketches of primitive grinders. For hundreds of years, man has used forms of them to sharpen his tools. In 1837, James Naismith, the same Naismith who invented the shaper, patented the first machine grinder. Charles Norton was one of the most famous manufacturers of grinders. When his employers, Brown and Sharp, were not interested in developing a large production grinder, Norton set out on his own. In 1903, he developed the Norton grinding machine. It could grind out an automobile crankshaft in just 15 minutes, a job that previously took 5 hours. It was a tremendous success. Henry Ford ordered 35 for his Model T plant. Grinders are best suited to work on extremely hard metal. Once steel is machined, it is often heated and cooled in a process that can cause distortions. Grinders are one of the few tools that can machine this heat-treated steel.
Grinding is generally a process that's applied when extreme accuracy is very important, because grinding can be highly controlled and it can be used to achieve levels of precision that would be impossible with other types of machine tools.
Today, grinders are used by the aerospace industry to shape metals like titanium, Inconel, and Hastelloy, extremely hard metals designed to resist high temperatures. These modern grinders are the most accurate of all machine tools. The best can grind a part to within 1/10,000th of an inch. The sixth type of machine tool is the most simple, the power saw. The first steam-powered sawmill was built in London in 1663. It was built not to cut metal, but wood. It caused riots among woodcutters who thought the power saw would replace them. Not to worry, it took another century for steam-powered sawmills to reach widespread use. By the mid-1700s, as blades became harder, power saws were installed in most factories to saw metal before it was machined. In the early 19th century, the invention of a power bandsaw was made possible by the improved flexibility of steel. The saw's rotating blade was flexible enough to wrap around rotary wheels, yet hard enough to stay sharp.
Power saws are often the first machine tool that raw material is going to encounter, even though they may not have the same glamour that other types of machines have. They're still extremely important parts of the manufacturing process, because they essentially create the workpieces that will go to other types of machine tools for complete manufacturing.
The seventh and final category of machine tool, the punch press, wasn't designed to cut or shave metal. It was made to press it into shape.
Metalworking is broken down into two different types. One, you have the production of parts by the removal of metal in the form of chips. And that's what we do on a lathe, on a milling machine, on a planer. But then beyond that, you have a form of metalworking which is the forming of metal by pressure, so that you use a press then to form it against a die.
Punch presses were one of the final machine tools to be developed. They have heavy rams on a flywheel that, when triggered, press down against a base. They shape metal over a die, a hard metal block that forms the metal into a particular shape.
When I was young, my father wouldn't allow me to leave the car door open. I'd open the car for some reason and leave it hanging on the hinges. Nothing doing. That was a wooden body. And it didn't hold its shape, so you had to slam the door. But nowadays, you can let the door hang all you want to. It's all steel body. And as the volume of cars went up, they started making the parts in presses instead of in woodworking shops.
Again, machine tools played a major role in World War I and World War II, as punch presses formed parts for tanks, jeeps, ammunition casings, and countless other war products. Today, as punch presses have become more complex and precise, they are used to shape metal into every conceivable shape for every conceivable use. Next, the new ultra-modern machine tools. During World War II, the machine tool industry built 800,000 new machine tools. Machine tools will return on Modern Marvels. While machine tools remain as a legacy of the Industrial Revolution, since the 1960s they have taken on a new level of sophistication, rivaling their initial design. The most dramatic changes have to do with how they are controlled. The earliest machine tools used flywheels to control the position of the tool and the speed at which it cut. Beginning in the early 1950s, those flywheels came under the control of paper tapes and punch cards, used to trigger a precise numeric routine. That routine could be easily repeated. The process was called numeric control. Numeric control was invented in 1947, when John Parsons put a milling machine under the control of an IBM punch card. It spawned a whole new world of machine tools.
The biggest change in machine tools occurred with the introduction of numerical control. That basically made it possible to automate the entire machining operation. Instead of relying on the operator turning hand wheels, the motion of the machine is basically directed by the numbers that are read off a tape and then translated into corresponding motions that will duplicate the shape that the designer had in mind.
Everybody thought this was a great innovation, where you had a paper tape that ran through a machine and you put your workpiece on. When machines became more automated, then they would have one man to set the machine up and an operator who simply put the workpiece in and push the buttons to start the machine, take the workpiece out, put another workpiece in, and there the responsibility was on the setup man.
Numeric control systems dramatically improved with the addition of computers in the 1960s.
That training and experience resides in the computer that controls the machine tool. And that's made it possible for the machine tool to do things that were simply impossible when they were operated by hand. We can do things that involve accuracies and shapes that would simply be beyond the capability of the machinist's ability to coordinate eye and hand to turn the wheels that move the workpiece or move the spinning tool against it.
Computer control means more fluid shapes can be made by the machine tools. One reason for the new modern fluidity seen in so many products. Fluidity that first had to be created on a machine tool. Robots have also been added to machine tools to move parts and change tools.
The automatic tool change mechanisms are unique mostly to the machining centers. In the machining centers, they can utilize many tools from